All right, so let us talk about PIC16F programming. So we had seen PIC16F 1619. This is the microcontroller that we are taking into account, and this is the board that we have seen. So in this session, what we'll do is we'll take up ADC potentiometer and we'll try to understand how we can read the potentiometer analog voltage to the ADC pin, and we'll try to find out analog to digital converter. Okay. So as you can see, we have this particular board that is there with us, and as we rotate this potentiometer, right side you rotate, more voltage will appear, and left side you rotate, less voltage will appear. Okay. So we'll try to program this and we'll see the variable value based on the ADC acquisition. So as you can see, if you want, you can go to this particular page, and you can find out the uh, development board as well. Let me open and show it to you. So what you can do is, this is the particular microcontroller that is there with us, and if you come down, just write down PIC16F 1619 in the Microchip website, and you will be able to find out this particular board. And in this one you will see that we have this particular microcontroller mounted on the board. And come down, once you come down, you will be able to find out we have demo board and evaluation boards. Okay, so you will see this is the curiosity board that I am using. I am actually using version 2, but this is revision version 4. So that's the reason it is showing little different. So this is the board that I am using. Okay. All right. So our aim would be to find out how to get the ADC in this particular session. So this is RC0 port 1. So what we'll do is, let us open our our circuit. I mean our program, and in this let us open MCC, and we'll configure my ADC point. Okay. So to configure that ADC point, make sure that ADC is connected to which line. Okay. So let us open this. Once we have clicked the MCC, it is loading. Once it is loaded, then you will see yes, we have resource management here. Okay. Now in this particular resource management, what we will do is come back to drivers. We have a lot of drivers like ADC, CCP, CLC. So each one of them we can see it later on, like how to generate PWM, how to do I2C, all these things we can do, SPI, UART, everything. Okay. But our aim is to do ADC. So in this ADC, just click it and click add ADC. Once you add ADC, then ADC will come here. So you can see ADC is added here. Okay. Now what is the aim that you will see here? ADC is connected here. Now put custom name, whatever name if you want you can put it, or let it be the default name. So I am not changing it. Now come back to result alignment. So result alignment I am going to do right side. Let the reference be VDD only so that it will take internal voltage reference. Our aim is to select the ADC channel. Okay, so based on the circuit, if you see, let me open the circuit and show it to you. So in this circuit, let us do here. So we have ADC connected to RC0. So RC0 point, we have to find out what is happening. So our aim is to see positive channel AN0 or AN1 or AN2. What is RC0 that is connected? So let us open the data sheet and see RC0 is connected to which line. So once you open the data sheet, you will be able to find out PIC16F 1619 or 15. All these things are there in this. So let us go to pin configuration. In this pin mapping, you will see here we have 14 pin and 16 pin. Then this is 20 pin allocation. Okay. So in 20 pin allocation, we have 20 pin PD package. Come back to RC0. So this is my RC0. You will see my A to D ADC converter is AN4. So basically RC0 pin is nothing but AN channel 4, like analog input channel 4. So in this analog input channel, we will select AN4. Okay. So this is how we have selected. Now if you want, you can reduce or increase the clock source. So it doesn't matter, like I will keep it by default. because system clock was 16, so f oscillator by 2, that is, it will become 8 megahertz. Okay, good. Now you will see your channel is not appearing here. Okay, so what is the thing that you have to do is get this pin grid view and come back to RC0. So you will see you have ADC. Now here also ADC, if you see, we have here reference and we have ADC channel. So RC0 is locked here. So once you select this, it should appear at this particular point. Okay, so you can see it is removed and getting added. See, it is removed, getting added. So once you have selected this channel 4 or AN4 or AN4 or RC0, so any of these names can be used to get that, like a argument. Okay, so this is that's all. Like, this is what we did. We have configured our ADC for channel 4 to RC0 pin. Now what is the next thing that we have to do? We have to generate the code. So once we have generated the code, then you will see come back to here, in our MCC generated file, you will see that we have ADC file added. Okay, so just double click this, you will be able to find out that my ADC file is generated, and in this we have like a lot of variables and all these things are there that we don't have to worry. What we have to try to find out is channel 4 is selected. Okay, that's one thing. Another thing is we have like ADC initialization, we have ADC select channel, and then we have ADC start conversion, then we have ADC conversion done or not, we have ADC conversion results. So lot of advanced programming can be done, but our aim would be to do ADC get conversion result. That's all. So ADC get conversion will be the function that I will be calling with the argument of this particular channel, and it will give me the result. Okay, if you go down, you will see .c file as well. So in this source file, you will see adc.c as well. Okay, so in adc.c, you will be able to find out all this initialization and everything is done. See, initialization is done, then like a select channel is done. Whichever channel will be fed, that channel will be later. Then we have a start conversion, then we have like conversion is done or not, and then ADC result, it will be right shifted, and then ADC get conversion. So this is how conversion will be coming, and you will be getting the result. Okay, now our aim is to write in the main file. So come back to your program. Okay, come to main. In this main, we will try to write down ADC function so that we can get the ADC result by moving our like potentiometer. So let us write down a program ADC value. So ADC value code, what I am going to do is I am going to initialize a variable. So let me just initialize one variable like let us say a simple variable, unsigned integer 16. I'll take and put ADC result value. Okay, so I am going to store my ADC result into ADC result value variable. Okay, now what we can do is we can put it like this, and then what we'll write down ADC get result, get conversion. That's all. And inside that conversion, you have to feed the value of a channel name. So what was the channel name? You could see in the resource management, go to this particular value, and you will see here channel name was channel underscore AN4. So here you have to write channel underscore AN4. That's it. So this is all that we needed in our function. Let me see what is if something is wrong. Yeah, I think it is okay. Okay, now let's compile the result and see if whether the result is coming or not. Build is successful. Now if you, yeah, loading is completed. Now if you want, you can program this. Okay. So once you program that, my board will be programmed and it will say that programming is complete. So I have connected the board, connecting to programmer, configuration memory erased. Yes, programming is completed. Okay. So you will be able to see like I am programming rotating the potentiometer and it is giving me the result. However, to see the result, let me do one thing. I will add this particular ADC result value to a variable watch window, and as I rotate, you will be able to see that result. Okay, so I will put a breakpoint here. Okay, come back to debug mode. So this was debug. Okay, so once we have debug mode, it will program again. Yes, it is running now. Now what I will do is, yes, it has run. So you can see I will, what I will do is I will go and put a variable here. Okay. So as you can see, ADC result is 0. Okay. It is already connected. If you want, you can manually write it down, not a problem. Okay. So ADC result value. Okay. So that will be added here. Understood? Anyway, automatically it had added, but not a problem. So this value right now it is showing 0. So if you go to next, then wait a moment, just run it. Let's see what is the value that is coming. So see, it is coming 038A. Okay, so 038A, if you want, you can convert it into decimal value and you will be able to find out. Okay, let me just show you quickly. So hex to decimal. So hex to decimal converter, 38A, right? So 38A is going to give you 906. Okay, so 38A is 906. Now I am going to rotate this, like left side, and it will become little lesser. So you will see I have rotated and rerun again. Let's see what is happening. Yes, 023B. If I rotate again, let me just show it to you first. 23B. So 23B is going to give you 571. Okay. Now I have rotated again. Let's rerun it again. So it will be middle of these two, 0 to be 8. Like that you can do. Now what I am going to do for your benefit is, let me give a like if else statement here. Based on the ADC value, I will switch on one of the LED on or off. Okay. So which LED is like vacant here right now? RC5 is there. Okay. So RC5 I am not using. Okay, let me set here. RC5 is here. Okay. RC5, RA2 is used, RA5 is not used. Okay, so what I will do is, whenever my ADC value is bigger than some like set value, we will try to set high. So let us say if my ADC result value is greater than or equal to, let us say, some number 600. Okay, so if it is greater than this, then what I will do is I will turn on my LED which is RA5, connected to RA5. So RA5 is which LED? You know already that this was the LEDs connected to RA5. Let me show here. RA5 is connected to LED D4. So LED D4 will be like high whenever my ADC result value is greater than 600. Okay, so let us stop running first and then write the code. Else I will keep RA5 as low. So set low. So whenever it will be less than 600, it will be set low. Okay, the spelling is mistake. ADC. Got it? Now let's. My code is ready. So let's compile it. Once we compiled it, now I'm going to program this particular value. Program this particular code. and we will see that whenever this value is bigger than 600, my D4 will be glowing, and whenever it is less than 600, it will be not glowing. So I'll go into debug mode so that you can see what is the value that is coming. Okay, until the time I'll just keep this also open right side. It will be easy for you. Okay, so it has run here. Now come back to variable. So variable value is 0 right now. Let's run it. What is happening? So you can see if I am running, my value is 0 to B6. Okay, and where is my D4? Let me just see in my board. So as you can see, D4 is actually glowing. So D4 is glowing, it means what? The value would be more than 600. So let's check it. What is the value? 2B6. So 2B6. 2B6. So 2B6 is 694. Understood? So 694, that means it is glowing. Now I will do one thing. I will rotate left side and my D4 will go low. Okay. So I have rotated left side, and let's run again. So as I can see, my board on my board D4 is off. So D4 is off. Why? Because 014C. So 014C is how much? 14C is less than 600. It is 332. Okay, so that's the reason it is off. And if you want it to be permanently working based on your like board, you just come out from debug mode and you directly program this board. So once you program this board, as and when you like rotate your potentiometer, whenever the value will go greater than 600, it will be on, and whenever it will be less than 600, your LED will be off. Understood? So my board is programmed. Right now it was off because it was less than 600. As I am increasing it, it has glown. Okay, so you can see based on your board if it is there with you. Okay, so if you do have any question regarding the ADC setting or all these things, you can reach out to me. And once more, I'll just tell you very quickly what you can do is, if you want to remove this, you can remove that. Okay, so if it is, are you sure you want to remove ADC module? Remove that. So it has been removed. If you generate code, ADC will go away, right? ADC will not be there. To add ADC, what you have to do? Go back, just add it. So ADC is added. Configure your channel, like put the name in the like ADC, then you put your alignment, right side, left side, whichever way you want, you can try by yourself. Select the channel name. So RC0 was AN4. That's all. And then we have a name not connected here. So come back to here, this particular pin package view. Select this particular channel. Add ADC. So ADC will be added here in the pin grid view. ADC will be added as RC0. So RC0 is added. Okay, that is analog channel 4. Understood? So even if you do not remember from the data sheet, you have to go and see. Otherwise, if you do not want to see from data sheet, what you can do is at least select RC0 here as ADC input, and that's how it will be automatically telling you what is the channel name that is there. Okay, so this is how it is mapped, and generate the code. Once you generate the code, you will see your ADC has been mapped. Okay, and to get the value, you have to just call this particular function ADC get conversion, and in ADC get conversion, feed the channel name, and channel name it will go and feed it. So once you go here, it will call this particular function in the adc.ce. So ADC get conversion, this is the channel name that this is taking based on the channel that you have fed in, and it is ADC conversion bit is on. Okay, and turn on ADC module. It is giving some microsecond delay, and then conversion done, it is checking. Once it is done, then it is sending the result. Okay, so this is how it is returning the result ADC address with like right shifting. Okay, so right shift I had done, that's the reason it is sending right shift. So hope you have a pretty good understanding about ADC reading and how to set the values. If you want to store multiple values, you can initialize an array ADC result value some 10 array, and all those ADC values you can keep on acquiring, and get a average value. So that is also done. All right guys, thank you.